Jai Hind everyone. My name is Swati Tomar and I work as an assistant professor in Akgec. So I've been taking the subject of big data in third year CSE, and today I'll be giving a lecture on Hadoop. So what is Hadoop? Hadoop is an open source framework that allows for the distributed processing of large data sets across clusters of computers using simple programming models. It is designed to scale up from a single server to thousands of machines, each offering local computation and storage at its core. Now, Hadoop has two main components: Hadoop Distributed File System and MapReduce. Hadoop Distributed File System, shortly termed as HDFS, is the storage unit. It splits large data files into blocks and distributes them across the cluster. Second one is MapReduce. This is the processing unit. It processes the data in parallel, making it super efficient for data tasks. It is used in various applications like data warehousing, log processing, recommendation systems, and more. Now, let's get to know the history. Let's get to know about the history of Hadoop. The history of Hadoop is quite fascinating. It all began in 2002 with the Apache Nudge project, which aimed to build a web search engine that could crawl and index websites. Doug Cutting and Mike Caffarella, the developers behind Nudge, realized that the project was too expensive to scale for indexing billions of web pages. In 2003, Google released a paper on the Google File System, which provided a solution for storing large data sets in a distributed environment. This inspired the Nudge developers to create the Nudge Distributed File System in 2004. Later that year, Google introduced MapReduce, a programming model for processing large datasets which the Nudge developers implemented. In 2006, the Apache community recognized the potential of NDFS and MapReduce for other tasks and formed an independent subproject called Hadoop. The name Hadoop comes from Doug Cutting's son, Toy Elephant. Doug Cutting joined Yahoo in 2006 to scale Hadoop to thousands of nodes. By 2007, Yahoo was using Hadoop on a 1000 node cluster, and in 2008, Hadoop became a top-level project at Apache. Many companies, including Facebook and the New York Times, started using Hadoop in April 2008. Hadoop made headlines by becoming the fastest system on the planet for sorting terabytes of data. The Hadoop Distributed File System is the cornerstone of the Hadoop ecosystem. It allows for the storage and management of large datasets across multiple machines in a distributed environment. Here are some key features. Number one is scalability. Number two is fault tolerance. Third one is high throughput. Fourth one is data locality. Fifth one is write once, read many. And sixth one is large datasets. Now, by scalability, we mean that the HDFS is designed to scale up from a single server to thousands of machines, each offering local computation and storage. Fault tolerance: data is replicated across multiple nodes. By default, each data block is replicated 3 times, ensuring data availability even if nodes fail. High throughput: it provides high throughput access to application data and is suitable for applications that have large data set. Data locality: HDFS moves computation to where the data is stored rather than moving data to the computation. This reduces network congestion and increases efficiency. The fifth one is write once, read many. HDFS is optimized for streaming reads of large files. Once data is written, it cannot be modified, which simplifies data coherency issues. Then comes large datasets. HDFS is designed to handle large files in the range of gigabytes, 2 terabytes and more. It divides these files into blocks and distributes them across the cluster. Now HDFS architecture, the HDFS architecture follows a master-slave model and consists of name node, data nodes and secondary name node. The master node that manages the metadata in namespace is the name node. It knows the file locations within the HDFS. Data nodes, the slave nodes that store the actual data blocks, they are responsible for serving read and write requests from clients. Secondary name node, not a backup but assists the primary name node in managing the metadata by taking periodic snapshots. Now, how does data flow happen in HDFS? When a client wants to read or write data, these functions happen. When the write operation is happening, the client contacts the name node for metadata. Name node provides a list of data nodes to store the data. Then client writes data directly to the data nodes. And what happens in read operation is the client contacts the name node for metadata. Metadata is data about data. Then name node provides the list of data nodes where the data is stored. Then the client reads data directly from the data nodes. Now Hadoop is a powerful ecosystem consisting of several components, each designed to handle different aspects of big data processing and storage. Here are the main components. Core components of Hadoop are: first one is Hadoop Distributed File System or HDFS. Now, what is the role of HDFS? Is that it provides scalable and reliable data storage. And what is the function of HDFS? Is that it divides large files into blocks and distributes them across nodes in a cluster, ensuring fault tolerance and high throughput. Similarly, the role of MapReduce is to enable processing of large data set in parallel. And what is the function of MapReduce? Is that it splits the job into map and reduces task processing data close to where it is stored, optimizing performance. Now, these are the ecosystem components of Hadoop. Yarn, shortly known for yet another resource negotiator. The role of Yarn is to manage and schedule resources. The function of Yarn is to allocate system resources to various applications running in a Hadoop cluster, ensuring efficient data processing. Now, Hadoop Common. The role of Hadoop Common is to provide shared utilities and libraries. Function of Hadoop Common is it contains that common Java libraries and utilities needed by other Hadoop module. Now, these are the data ingestion tools. First one is Scoop. Second one is Flume. Now, the role of Scoop is to facilitate data transfer. What it does is that it transfers bulk of data between Hadoop and relational databases. Now, Flume, the role of Flume is to collect and transport log data. Function, it ingests streaming data into Hadoop for processing. Now, these are the data processing tools. First one is Hive. The role of Hive is data warehousing and SQL-like querying. Function of Hive is to provide a SQL-like interface for querying data stored in HDFS. Now, Pig. Pig is also a data processing tool. What it does, the role of Pig is to do high-level data processing. Function of Hive is to use a scripting language called Pig Latin for writing data analysis programs. Now, data storage tools these are some data storage tools: HBase and Cassandra. Now, what is the role of HBase? Is that it is a non-relational distributed database. Function of HBase is that it stores large amount of sparse data and provides random real-time read-write access. Another data storage tool is Cassandra. The role of Cassandra is that it distributes no SQL database, and the function of Cassandra is that it manages large amount of structured data across many commodity servers without a single point of failure. Now, data serialization and coordination. There are some tools of data serialization and coordination. Some of these are First one is Avro, second one is Zookeeper. The role of Avro is that it does data serialization framework, and the function of Avro is that it provides data serialization and data exchange services for Hadoop. Second is Zookeeper. The role of Zookeeper is that it provides coordination services. Function of Zookeeper is that it manages distributed application by providing services like configuration, now data analytics and visualization. Now these are the tools for data analysis and visualization. The first one is Mahout. The role of Mahout is machine learning. It is a machine learning library. Now function is that it provides scalable machine learning algorithms for clustering, classification and collaborative filtering. Now second one is Oozie. The role of Oozie is that it is a workflow scheduler. Function of Oozie is that it manages Hadoop jobs as directed acyclic graphs of actions. Third one is Ambari. The role of Ambari is that it does cluster management. Function of Ambari is that it simplifies the provisioning, managing and monitoring of Hadoop clusters. In the Hadoop ecosystem, data formats play a crucial role in storing, processing and managing large data sets efficiently. Here are some common data formats used in Hadoop. The first one is text format, second one is binary format. Now in text format, there is a plain text format and there is a comma separated values or CSV. Plain text, description of plain text is that these are the simple text files with new line separated records. Usage of plain text is that it is easy to write, read, but not space efficient and lacks schema information. Second type of text format is comma separated values or most commonly known as CSV format. Now these are the text files with comma separated values. Usage of CSV is that it is widely used for tabular data but can have issues with delimiters within fields. Now binary format are of two types. First one is sequence file and the second one is Avro. Now description of sequence file is that binary format for storing key value pairs. This usage of sequence file is that it is efficient for map reduce, input, output, supports compression. Second one is Avro. The description of Avro is that it is a data serialization system basically that uses JSON for defining schemas and binary format for serialization. Usage of Avro is that it supports schema evolution and is used for data exchange between programs. Now then comes Parquet. Parquet is also another type of text format in Hadoop ecosystem. Now Parquet is a columnar storage format. It is efficient for analytics, supports complex nested data structures and enables higher compression rates. Then another type of text format is optimized row columnar, also known as ORC. Now it is a columnar storage format optimized for read performance. It is most commonly used with Hive, provides high compression and fast query performance. Now these are the specialized formats: RC file or record columnar file. It combines row and columnar storage approaches. It is used in Hive for better performance than plain text formats. Then comes Thrift. Thrift is a data serialization format that supports various programming languages. It is used for RPC or remote procedure call and data serialization. Now choosing the right format. How do you decide that which format to choose? Now every format has its own advantages and disadvantages. For example, if you want to go for text format, it is very simple to use but it is less efficient. So if you go on deciding using binary formats, now binary formats are more efficient, right? It supports compression and schema evolution. And if you want to go for columnar formats, it is ideal for analytics and query performance. Now each format has its strengths and trade-offs. The choice depends on the specific use case, such as the need for compression, schema evolution or query performance. Now how do you analyze data with Hadoop? If you are analyzing data with Hadoop, it involves several steps from data ingestion to processing and querying. Here is a high-level overview of the process. First one, data ingestion. Before you can analyze data, you need to bring it into Hadoop ecosystem. Tools like Scoop and Flume are commonly used for the purpose. Scoop transfers data between Hadoop and relational databases. Flume collects and transports large volumes of log data into HDFS. Second is data storage. Once the data is ingested, it is stored in the Hadoop distributed file system. HDFS provides reliable and scalable storage for large data sets. Then the third one is data processing. Hadoop offers several frameworks and tools for processing data. Now, these are the some of the tools and some of the frameworks mentioned here. For example, MapReduce, a core component for distributed data processing. It splits data into independent chunks and processes them in parallel. Second type of tool is Hive. Hive provides a SQL-like interface for querying data. It's ideal for those who are familiar with SQL. Now there is Pig also. What does Pig do? Pig uses a scripting language called Pig Latin for data transformations and analysis. There is another framework known as Spark, a fast and general purpose clustering computing system. It offers in-memory processing for better performance compared to MapReduce. Now data querying. For querying and analyzing data, we can use the following tools like Hive. What does Hive do? Hive enables SQL-like querying on large data sets stored in HDFS. Impala, a parallel processing SQL engine that provides low latency queries. Now there is Drill. Drill allows SQL querying on various data sources including HDFS and NoSQL databases. Now, if you are doing data analysis, Hadoop provides tools for machine learning and advanced analytics. For example, Mahout offers scalable machine learning algorithms for tasks like clustering, classification and collaborative filtering. mlib is a part of Apache Spark, a library for scalable machine learning, including tools for classification, regression, clustering and collaborative filtering. This is an example workflow. First, what you do, data ingestion happens, then data storage is done, then data processing happens. The fourth step is usually data querying and the fifth step is data analysis. Now, what happens in data ingestion is that it uses Scoop to import data from a relational database into HDFS. Now, when you are doing data storage stores the ingested data in HDFS. Now, in data processing is done with the help of MapReduce or Spark. What we do is we clean and transform the data. Now, data querying, what happens in data querying? Query the processed data using Hive or Impala. Now, the last and the final step is data analysis. Apply machine learning algorithms. Now, we are going to apply Mahout or mlib, these kind of machine learning algorithms for performing data analysis. Now, there is a term called visualization. If you want to visualize the results, how are you going to do that? Now, you can either use Hue or you can either use Tableau. These are the visualization tools. How does Hue helps in visualization? Hue is a web-based interface for Hadoop that includes tools for querying and visualizing data. Similarly, Tableau connects to Hadoop and provides powerful data visualization capabilities. So far, we have studied about the history of Hadoop, introduction of Hadoop and the components of Hadoop. Apart from that, we just came to know about the text formats of Hadoop, right? What kind of text formats are there in Hadoop? So, in the next lecture, we will be studying about like real world examples of Hadoop, okay, or steps to analyze the data with Hadoop. These will be the topics that we will be covering in the next lecture. So this will be all for today's session, and I will be seeing you in the next lecture. Thank you.